Ganpataye. Good morning, good evening to all. Welcome to my channel Chiranjeevi Talks on Vedic Mathematics. Good evening. I can see only 11 students who took the membership. 11 students took the membership. Good evening. Yeah. Okay, sorry, good evening. 11 students took the membership. Morning activity I kept it in the Instagram as well as YouTube. Is the board visible, students? Take the membership as early as possible. Yeah. Today we are going to discuss conditions of consistency. Conditions of consistency. Consider the pair of equations linear equation in two variable general form, where a1, a2, b1, b2, c1, c2 are real numbers, and a1, a2, b1, b2 must not be equal to 0. Okay? Now, see, there are three conditions of consistency. Three conditions. First condition is a1 by a2 is not equal to b1 by b2. a1 by a2 is not equal to b1 by b2. Means the coefficients ratio a1 by a2 and b1 by b2, if you observe they are not equal, the ratio is not equal, then you can say that these two, when represented in the graph, we can observe intersecting lines. When we represent those two equations in the graph, okay, we can observe two intersecting lines. And we know that if two lines are intersecting, we can get only one common solution. If two lines are intersecting, that means they will meet at only one point, and that point is known as common solution. Okay? Now, second condition is a1 by a2 is equal to b1 by b2, but not equal to c1 by c2. The first two ratios are equal, means ratio of x coefficients equal to ratio of y coefficients, but these two are not equal to ratio of constants. a1 by a2 equal to B1 by B2 but not equal to C1 by C2. Okay. Then the lines are parallel. That means no common solution. No common solution. Okay now? Now, if all the three ratios are equal, then we can say that both the lines will coincide each other. That means we can have infinite number of common solutions. Then those two lines will have infinite number of common solutions. Don't say infinite solutions, infinite number of common solutions. Is that understood? Now, if the given pair satisfies this condition and this one also, we can say that they are consistent pair of equations. We can say that they are consistent pair of equations. If the given equations, if they satisfy then we can say that the given pair is consistent pair of equations. Okay na? Either this condition or this condition is satisfied, consistent pair. If the middle one is satisfied, we can say it as inconsistent pair. Inconsistent pair of equation. Okay na? Now, there is another one, dependent and independent. See, consistent and this one also consistent. This is inconsistent. Okay na? Now, if any pair of equations satisfies this condition, we can say that they are independent pair of equations. Inconsistent and independent pair of equations. Okay na? They are not dependent on each other. Okay, and this, if any pair satisfies this condition, we can say that they are dependent pair of equations. Okay na? Now, what about this one? You cannot say that the pair totally dependent, but they are dependent at only one point. Even this pair is also dependent, but at only one point. They are dependent pair, but at only one point. You cannot say that they are dependent throughout. This, the pair which is having infinite number of common solutions, we can say that they are dependent pair of equations, because both the pairs or both the lines, they will coincide each other. Is that right? So they are dependent pair of equations. And here it is, even it is also dependent pair, but it is dependent at only one point. Okay, na? Now, sir, what is the use of knowing all these three conditions? The question will arise. What is the use of knowing all these three conditions? Can anyone say? What is the use of knowing these three conditions? Anyone? Or is it necessary to know? Easy to plot in the graph. We can know it before even solving the whole problem. We can find out, do we have zeros or not, to know the number of solutions. Jitasri. Plot without graphs. Aditya, who is this Aditya? Deciding whether the pair of equations are consistent or inconsistent. We can check if they have common solutions or not. Vanshika Kolluru. Sir, to find whether the lines are parallel or coincident. Yeah. Actually, suppose a pair is given to you. A pair is given to you like this, and I asked you to find out the solutions, find out the common solution for this pair using graph. This is my question. Find out the common solution for this pair using graph. If this is my question, then if you do it taking 3 solutions for this, taking 3 solutions and for this, and drawing its graph, and at the end you came to know that after seeing the graph, after drawing the graph, you can see that these two lines are parallel, then no common solution. After doing all these work, finding the 3 solutions, taking the graph, plotting the points and joining them, and after half an hour, you came to know that the lines are parallel. So your half an hour time is wasted, and you will say that no common solution. You will say that no common solution. After doing all this, after wasting this much time, then you will say that no common solution. Okay, na? But if you know the conditions of consistency, and if you apply A1 by A2, 2 by 4, which is 1 by 2, B1 by B2, minus 3 by minus 6, which is also 1 by 2, C1 by C2, minus 6 by minus 10, which is 3 by 5. So A1 by A2 is not is equal to B1 by B2, not equal to C1 by C2. The pair is independent pair and inconsistent pair. So parallel lines, no common solution. So no need to draw the graph. simply you can say that the given pair of equations satisfies the condition a1 by a2 is equal to b1 by b2 not equal to c1 by c2. So when we draw the graph of it, we will get parallel lines, and we know that parallel lines will not intersect each other. So the common solution is 0, means the given pair is not having any common solution. That's all. It will take only 5 minutes. It will take only 2 to 3 minutes, not even 5 minutes. 2 to 3 minutes to complete it. Is that right? So this is the use of conditions of consistency. Okay na? And even by using these conditions of consistency, we can solve the we can find out the unknown coefficients also. Unknown coefficients. We will see some problems. Using the conditions of consistency, we can find out the unknown coefficients also. We will solve some problems basing on that now. Yeah. Right. Kx plus 3y is equal to k minus 3. 12x plus ky is equal to k. Okay na? So this pair is having infinite number of common solutions. This pair is having infinite number of common solutions. That is given. It is having infinite number of common solutions. And we need to find out k value. Okay. Now, what is the condition for infinite number of common solutions? a1 by a2 is equal to b1 by b2 is equal to c1 by c2. Once again, the given pair is having infinite number of common solutions, so they satisfies this condition. They satisfies this condition. Okay na? Now, substitute the values. K by 12, 3 by k, k minus 3 by k. Okay na? Now, we need to find out k value. So what do you do it? You can consider either these two ratios or these two ratios or these two ratios. Your wish. You can take any two ratios. Okay na? I am considering the first two. K by 12 is equal to 3 by k. Do cross multiply. K square is equal to 36. K is equal to plus or minus 6. K is equal to plus or minus 6. Okay na? Now, if I consider 6, then the equations will be 6x 3y is equal to 3, 12x 6y is equal to 6. Children, you can observe here 1 by 2, 1 by 2, 1 by 2. All the three ratios are equal. Now, if I consider minus 6, minus 6x plus 3y minus 6 minus 3, which is minus 9. 12x minus 6y minus 6. Okay na? Now 1 by 2 minus 1 by 2 minus 1 by 2, but negative 9 by negative 6, it is 3 by 2. It is 3 by 2. That means a1 by a2 is negative 1 by 2, b1 by b2 is also negative 1 by 2, but c1 by c2 is 3 by 2. Epudu if k is negative 6, if k is 6, if k is 6, a1 by a2 is equal to b1 by b2 is equal to c1 by c2. 1 by 2 is equal to 1 by 2 is equal to 1 by 2. If k is 6. If k is minus 6, a1 by a2 is equal to b1 by b2 not equal to c1 by c2. So we cannot consider k is equal to negative 6. We cannot consider k is equal to negative 6 because of this reason. Understand? So k value is only 6, not minus 6. Is that understood? Good. We'll see one more problem. We'll see one more problem. Now, one more problem. All the problems? Yeah, no common solution. Yes, good. Yeah, this one. X plus 2y is equal to 5. 3x plus ky is equal to 15. This pair is having no common solution. No common solution. Now, what is the condition for no common solution, children? Condition for no common solution. Anyone? Yeah, they'll give you. They'll give. What is the condition for no common solution? A1 by 2 equal to B1 by B2. Very good. A1 by A2 is equal to B1 by B2 not equal to C1 by C2. Vaishnavi Kesani. Very good girl. Now, write down the ratios. 1 by 3 is equal to 2 by k, not equal to 5 by 15. Okay na? Now we need to find out k value na? Do cross multiply. K is equal to 3 into 2. K is 6. K value is 6. Now keep 6 over here. X plus 2y is equal to 5 by 15. 3x plus 6y is equal to 15. Okay na? Now this is 1 by 3. Even this one is also 1 by 3. I think this is minus 5. Yeah, that is minus 5. Got it. Minus 5. Then negative 1 by 3. 1 by 3, 1 by 3 and negative 1 by 3. A1 by A2 equal to B1 by B2 but not equal to C1 by C2. Okay na? So no common solution. No common solution. Is that understood, children? So the conditions of consistency are very, very important in solving the pair of linear equation in two variables problems. Okay. And you can find out the unknown coefficients also, that is k values. Board exams, this is an important model. For board exams, this is an important model, finding the k value in pair of linear equation in two variable for 3 marks, either 2 marks or 3 marks. You can see a problem on this. And the students who did not take the membership, please kindly take the membership immediately. Once again, students who did not take the membership, kindly take the membership immediately. Now. Okay na? And who took the membership? Very good. And who did not take the membership, take it immediately. Take it immediately. Okay na? Dhanyavad. Thank you very much. Mahaganadhipataye Namaha. Weightage for this chapter 10 marks? No. Maybe 6 marks. 6 or 7 marks. Total algebra is for 20 marks in board exams. Total algebra. Algebra means 5 chapters. Real numbers, polynomials, pair of linear equation, two variable, quadratic equations, arithmetic progression. Total 20 marks. All these 5 chapters consist 20 marks. Okay na? Thank you very much. Dhanyavad. Take the membership immediately. Thank you. Bye. Thank you.